Okay, so we're going to look at the graphs of trig functions. And this video probably looks a little bit different because I'm doing it on Zoom, because I'm going to want to write some things out here, but I'm also going to want to do a couple things on the computer where I want to do a screen share. So I want to show you Desmos, which you may or may not have seen, but it's a really nice graphing software that's on the computer. So we've defined the trig functions in terms of the unit circle, right? And so you got your angle as you rotate around, okay? And then, for example, and I'm going to start with this, y equals sine of theta, okay? And so the sine of theta, your theta is your angle, and the sine is the y coordinate, okay? So I want to put these points here. So this is 1, 0. This up here is 0, 1. This one is negative 1, 0. And right here, you got 0, negative 1. And so this is like 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these are like your quadrant angles, and they play an important role in graphing these trig functions. So what I usually say is when you make a graph, you should graph those 4 quadrant angles along the x-axis. Those are the ones that you should show on the x-axis. Okay, so for this basic sine, what I'm going to do is I'm going to graph this from negative pi over 2 to pi over 2. Okay, so this would be like negative pi over 2, and this over here. I'm sorry, not pi over 2, negative 2 pi to 2 pi, sorry. So I'm going to graph from negative 2 pi to 2 pi. And that's not very good. This should actually probably be out a little bit more. It should be like this. So this will actually be negative 3 pi over 2 probably. So let me show you what I do then. This is how I do it. I go 2 pi, okay, and then I cut this in half, and this would be my pi. And then I cut that in half, and this would be my pi over 2. And then I cut this one in half, and that would be my 3 pi over 2. So normally that's what I would do here. I would go to negative 2 pi. I would cut that in half. I'd get negative pi. And then I'd cut that in half. I'd get negative pi over 2. And then I'd come here, cut that in half, and I get negative 3 pi over 2. Okay? Now, the sine of theta is always going to oscillate between negative 1 and 1, because that y-coordinate isn't going to be any smaller than negative 1. It isn't going to get any larger than positive 1. So this will be 1, and this will be negative 1. Okay? And basically, this is going to make this wave. We call it a sine wave. Okay? So at 0, notice the y-coordinate is 0. So it actually starts here at 0. And then as you go from theta, from 0 to theta pi over 2. So as the angle goes from 0 to pi over 2, this y-coordinate goes from 0 up to 1, right? It goes up to 1. Okay, and then this actually has a curve. It looks kind of like this. It's this concave outward, this concave downward kind of curve, and then it's going to go down like this. So as you go from pi over 2 to pi, this is going to go from 1 back down to 0. So it looked like this, right? And then it's going to go, as you go down here, it's going to go down to negative 1 here. And then it'll go back up to, when you go back up to 2 pi, it'll go back up to 0. So it'll look like this. It'll have this curve, and then it'll be like this. Okay, and there you go. That's actually a real nice one cycle of the sine wave. And it says you go from 0 to 2 pi, and then you could go around the circle again, and it would repeat the wave, and then again, and then again. Okay, and then if you go in the negative direction, notice it goes down to -1, up to 0, up to +1, back down to 0. So this would just kind of continue the wave on backwards, like this. Okay, and so this wave it oscillates up and down between -1 and 1. Okay, and these 4 quadrant angles kind of represent when it's in the middle, maximum, back to the middle, minimum, back to the middle, maximum, back to the middle, minimum. And those are the quadrant angles. And so I say always graph those quadrant angles down here. And in fact, what you can do, let me actually graph y equals cosine theta here. What you can actually do is I go 2 pi, I go half of that is pi, and then I don't mark these because it can get a little busy there. So I just put those halfway marks there. So this is -2 pi. This is pi, and then these are those halfway marks. And then cosine is going to go between 1 and -1 as well. Okay. Except cosine actually starts at 1 and then it goes down to 0. So it'll go like this, starts at 1, goes down to 0, and then this will go to -1, up to 0, and up to 2 pi. So this is from 0 to 2 pi, and this one doesn't look like a full wave. It just looks kind of like one of those. It's really this kind of piece, right? So to really get to see the wave, you have to continue it backwards like this. And this thing is basically the exact same wave. It's just starting at a different place. So I always remember that the sine starts at 0 and goes up, back down, down, back up, and so on, while cosine starts at 1 and goes down. Okay, so sine starts at 0, goes up, and the wave continues. Cosine starts at 1 and goes down, and the wave continues. Okay, and this here is considered like the original cycle. This is the original cycle. And what we would say here is that the period of the graph is 2 pi. In other words, once you've gone 2 pi, then it just repeats itself. Every 2 pi, it repeats itself. That's the same here. The period is 2 pi. Okay. We would say that the amplitude of the wave here, the amplitude is the distance from the center of the wave. And I call this center the axis that it oscillates about. So that axis here, okay, is the middle portion, and the distance from that axis out to the minimum and maximums, that distance is the amplitude. So the amplitude of each of these is just 1. So the amplitude is 1, but the distance that it oscillates from the minimum to the maximum is going to be 2. So it's double the amplitude, right? And then you have that the domain of this is -infinity to infinity. Okay, same here, domain -infinity to infinity. Okay, and you can't, I was going to say that you can put in any real number here. But the range here is just -1 to 1. It can't go any more than 1 or any less than -1. So these are like square brackets, -1 to 1. But it can include the -1 to 1. And this range is -1 to 1. And those are like your sine and cosine waves. And really, they are the same graphs. If I took this and I shifted it over 1 quadrant, look at this, it would actually start here. It would, if this shifted over to this point, it would actually be the sine graph, wouldn't it? So if I actually shifted this one, I would actually get the sine graph, okay? So I want to show you maybe the tangent here. Maybe I will do, yeah, I might do that here. Let's do y equals tangent of x. Let's see if I can fit it in here. The tangent here, I'll let this be 2 pi over here, -2 pi. And then you got pi, right? and then you got, that's negative pi over 2, and this is pi over 2, and this is negative 3 pi over 2, and this is 3 pi over 2. Now what I want you to notice with this is that tangent of x is y over x. So whenever the x coordinate is 0, the tangent of x is going to be undefined, and in fact it'll have a vertical asymptote because you're going to get a 0 in the denominator. So when does the x coordinate equal 0? Well, at pi over 2 and 3 pi over 2. At those, it's going to equal 0. So I'm going to put this dashed line here. And those are asymptotes. Okay, those are asymptotes. And if you think of the tangent as being the slope of the line, so if you're down here at negative pi over 2, you're at negative infinity, right? You're a vertical line. And then what you do is this becomes negative. These are negative slopes, but they level out until you get to 0. And then you spin back up, and then you go from 0 up to positive infinity. And so what you actually get is it comes up from negative infinity, like this, and then it kind of goes to 0, and then it switches back around, and it goes up to positive infinity. And then it actually is going to repeat itself again. So here is negative infinity. The slope of that line is negative infinity down to 0, and then 0 up to positive infinity. So this will actually repeat itself like this over and over again. You'd have another asymptote here, right? And so to me, this kind of looks like the cubic y equals x cubed function, but it's not, because it's trapped between negative pi over 2 to pi over 2. Each piece is trapped, and this is basically, this has a period of pi. So every pi, it repeats itself. So I could say that the period here is pi. Amplitude, well, this isn't a wave, isn't it? So this amplitude does not apply. The domain here, is it negative infinity to infinity? Actually, it's not, because it's not defined at every pi over 2, right? And so how can we write this? We can say all real numbers except let's see if I can do this. Except x equals k pi over 2 and x equals k 3 pi over 2. And so the idea here is, I don't know if this actually gives it to you, because you could put in nope, this is how I want to do it. I don't want to do this, sorry. I should say except for every pi over 2 plus k times pi. Okay, so if k were 0, right, you would just get pi over 2. If k were 1, you'd get 3 pi over 2. If k were 2, you would get the next one. Okay, every pi. And then if k were negative 1, you would get negative pi over 2, negative 3 pi over 2, so on. So this is where k is an element of the like dot dot dot, negative 3, negative 2, negative 1, 0, 1, 2, 3, dot dot dot. And these are the integers basically. Okay, so I wouldn't worry about this a whole bunch, but you just know that there's the asymptote for each of those angles. Now the range here is easy. It's negative infinity to infinity. Okay, so it actually takes on every possible value from negative infinity to infinity, and it does it over and over again. Okay, so that's the tangent. So what I did here then, underneath this, is I have a graph of each of the trig functions, just to give you a quick overview here. So here's the sine and here's the cosine, just like I showed. And those, you know, the sine starting at 0 goes up to 1, down, and it oscillates. The cosine starting up at 1 and going down. So here's the tangent down here, just like I showed, from negative pi over 2 to pi over 2. Okay. And this has a period of pi. So the cotangent here is a lot like the tangent, but for the cotangent is x over y. So this is going to have an asymptote whenever the sine is 0. So it'll have an asymptote at when x is 0, when x is pi, when x is 2 pi, right? And so these dashed lines are the asymptotes. And it's actually the same graph as this, except it's flipped around. So it's basically that flipped around and shifted over. So the asymptote here is the y-axis. It goes down and then approaches this axis here. And it keeps repeating that. It's the same graph as tangent, but it's flipped over. And you get your asymptotes at all the multiples of pi. So I could say that the domain here is all real numbers, all real numbers except x equals k pi. Okay, so 0, 1, 2, -1, -2. So this one's a little simpler here. Okay, so what about these? These are the secant and the cosecant, okay? And so here's the sine. So this one's the cosecant. And what I want to show you here is the relationship between these two graphs. So if I draw the sine, it starts at 0, goes up to 1, down to 0, down to -1, up to 0, like that. And this will go down, up, down, up. Okay, and so basically, whenever this thing crosses the axis, whenever the sine graph crosses the axis, you get an asymptote for the cosecant. It makes sense because cosecant is 1 over y, and whenever y is 0, the cosecant will be undefined. And then this thing, these are like two asymptotes, and this is kind of like a parabola, but it's not a parabola because it's trapped in between there. It comes down, touches it at the maximum point, goes back up. And then it comes up, touches it at the minimum point, goes back down. And that's how that works, okay? So similar with this one, whenever the cosine is equal to 0, whenever it crosses the axis, you get this asymptote, right? And then I drew that wrong. This should have been right here, not here. I drew those wrong. I'm so sorry. So these should be the asymptotes whenever it crosses the axis, and then this will go down, up, up, down, like that. Right? And so I could do it like this, graphing the cosine starting at 1, going down, down, up, like that. Okay? And so what about the domain and ranges here? Well, these have similar domains as these down here, okay, because you're going to be undefined at the same points that the secant at the same point the cotangent's undefined. Sorry. Secant will be the same as when, the secant is 1 over cosine, and the tangent is sine over cosine. So these two will have the same asymptotes. These two will have the same asymptotes. Okay, but notice the range for these here. The range is going to be -infinity to 1, and it'll include 1, and then have the union symbol, and then 1 to +infinity. And that'll be true for both of these. Okay, and the period for both of these is 2 pi. Okay, and the amplitude, this you don't say anything about. The amplitude does not apply here. Okay, but those are the 6 trig functions. Okay, so now what I want to do is I want to do a screen share here, and I want to show you Desmos and some of the stuff that it can do. So let me go to the screen share, and so hopefully, oops, let's see. Here we go. So hopefully I'm showing you the right thing here. Let me stop share and make sure I'm getting it. Okay, I'm going to hit screen share, and what I want to do is get this and then hit share. I think I'm sharing you. Hopefully I'm sharing you the Google thing here, and what I have in my little screen is something else. So, okay, so what I'm going to do here is I'm going to type in Desmos, so just DESMO, and that'll give me DESMO, I think S, Desmos, and click return. And you may or may not have seen this. Maybe a teacher has shown you this. You've used it in a previous course, but it's a really neat graphing software, and it can do all kinds of awesome stuff. You just get to it that easy in Google, and then you hit start graphing, and you get this nice graph, and you can zoom in and out and do all kinds of neat stuff. Okay, now what I'm going to do is I am going to can I minimize this? So I'm going to go to this tool, and I want to do this in terms of radians. And so then I want this to be 2 pi. So I want the x-axis to go from negative 2 pi. So I just write pi for pi. And then I want this to be 2 pi. So that it goes like that. And then I want my step to be pi over 2, not the units 1, 2, 3 or whatever. So I'm going to go pi over 2. Okay, perfect. And then my negative axis, maybe I'll just do this from, we'll say negative 5 to 5. And then I'll have my step be 1. So the step is just the scale there. And this is perfect. So I'm going to just use that as my axis. So this is divided up into my 4 quadrants, as you can see. So to change it to that window, I went up here and I clicked on that tool. Okay, and that's where you can change it. So now I'm going to go over here, and I'm going to type in just y equals sine, y equals sin sine, and then I just put an x, and immediately there you have it. Okay, so what I want to show you now is some of the things that can change this graph. So if I want this thing to oscillate, let's say between negative 3 and 3, then what I can do is I can put a 3 out front, and that changes the amplitude. See that? Or if I put a negative 3, what that does is it not only stretches it so that it goes between negative 3 and 3, but instead of starting at 0 and going up, it starts at 0 and goes down. So it stretches it. Oops, it stretches it and flips it. Okay, so if I take away that negative here, it would look like that. Okay, so you can do all kinds of things like that, change the amplitude. Now here, let me change it to 2. So here, I can actually move that graph up 1. So if I hit plus 1, it moves it up 1. See that? If I move it up 2, it moves it up 2. And now this is actually oscillating between 0 and 4. I'm sorry, between 0 and 4. oscillating like that. So this is my vertical shift, and I want the vertical shift. If I want it to oscillate between 0 and 4, then this needs to be halfway between 0 and 4. Okay, so let's say I want it to oscillate between 0 and 5. Then what I need to do is halfway between 0 and 5 is 0.5, 2.5, but then my amplitude also has to be 2.5. And now my graph is oscillating between 0 and 5. See that? Let's say I want it to oscillate between, let's say between 1 and 4. So if I want it to oscillate between 1 and 4, let's say, I got to find the halfway mark between 1 and 4. So that would be 4 plus 1 is 5, divided by 2 is 2.5. Okay, so that means this is going to be 2.5. So that'll be my middle part, but then this thing here, it'll need to go from 2.5 up to 4, and then 2.5 down to 1. And so my amplitude's just going to be 1.5. And now it's going to oscillate between 1 and 4. Okay, so by changing these amplitudes and changing these vertical shifts, you can get it to oscillate between any two values. Now let's say I want this thing though to start at the minimum and then go up to the maximum and back down to the minimum. You can do that, but what I'm going to do is I'm going to use the cosine function, because the cosine actually starts at 1 and goes down. But if I want to start at the minimum, then I need to flip that cosine around. So I can put a negative here, and I can flip it around. So now it's going from the minimum up to the maximum, back down to the minimum. Okay, so you can do all kinds of things here. So now let me take those away for a minute. And we can do cosine or sine. I'll do sine. And what I want to show you here is, so here's sine of x. Maybe I'll just put sine of x. And I'm going to keep that there. Oops, let's see. I'm going to keep my sine of x in place. Let's see. Sine x. Okay, there's my sine x. I'm going to keep it there, but now I'm going to go to the next line, and I'm going to change my period of it. And the period is how fast it oscillates. Okay, so what I want it to do is I want it to do 2 cycles in the same amount of time. And so if I multiply the x by 2, you can see that it didn't do it, but I know why. I don't have an equals here. There we go. You can see now this thing oscillates. It does 1 cycle in half the time. Okay, and then it keeps oscillating like that. Or if I want it to do, I could do 4, and now there's 4 of them. Or I could do 20, and then it goes crazy, right? Or I could actually make this 1/2 like that, and then it stretches it out, and so from 0 to 2 pi it only does half of the wave. Or if I make it 1/4, it just does 1/4 of the wave, right? But I could zoom it out if I wanted to, and you could see that it'll do the whole thing, but the new period is now 12 pi. Okay, oop, not even 12 pi, sorry, because it has to go back up. The new period is actually 16. Wait, up, down, there. The period is 8 pi, sorry. So the period is 8 pi, and then it goes through and does it again. But you can see that you can change the period by changing the number inside the sine function multiplied by the x, okay? And so now these two are the same here. So let me go back. I want to get still want to get a good, there we go. That's good. Okay. So so now, oops, I don't want that. Let me get it back. And maybe I'll go to my tools and I'll change this y-axis back to from 5 to 5 again. Okay. Okay. Well, now what I want to do is, let's say I want to shift this over. Remember I said if I took the sine and shifted, well, it was actually the cosine. Let me actually take the cosine here. There's my cosine graph. Remember I said if I took the cosine and I shifted it this way, pi over 2, it would actually line up with the sine graph, wouldn't it? So the way that you shift it here, I want to shift it to the right, and so I'm going to subtract. Remember, a horizontal shift is counterintuitive, so I'm going to shift it pi. So, but not just pi, I'm going to shift it pi over 2. So that's the cosine graph shifted over pi, but pi over 2. And then you see that it actually lined up there, didn't it? Okay. So let me actually get rid of this. And so here I could shift it over, you know, I could shift it over 3 pi over 2. Okay, and then let me actually add the cosine. Y equals cosine of just x. Okay, so what I did, this green one is the cosine of x, right? And so what I did is I took that and I shifted it over 3 pi over 2, and then that's where the blue one came from. So the whole graph, this is the green is the cosine, and then I shifted it all the way over here. So this blue one is a horizontal shift of the other cosine. And so this is called a phase shift. So this horizontal shift is called a phase shift. And they're actually pretty easy to do if they are the quadrant, if they end up being one of those quadrant angles. And otherwise it can be a little tedious. So let's say I do 5, I want to shift it just pi over 6. So then that basically is just shifting the graph over, shifting the green is the regular cosine. I just shifted it over 30 degrees, or pi over 6, right? Or if I did pi over 3, that would shift it over a little more, right? If I added that, that would move it back. So if I added, instead of, then that would move that graph back, okay? But you can see then how those work, okay? Those are called phase shifts. So you can change the period, you can change where it starts, the phase shift, you can change the amplitude, you can change the whole graph, translating it up and down. Do all kinds of cool stuff, okay? Now let me show you one more thing that you can do on here if you've never worked with this. I can do something like A, and then do sine, and then in parentheses, I can do maybe something like, I'll say BX, and then in parentheses. And so what I can do is I can create, this is like a slider, and then I can slide I can change my A values. Let me do a slider for my B as well. Okay, so this is going to change the amplitude. See that? So here it is at 0. Oops. Here it is at 1, which is the regular, just the regular sine function. And then this is going to increase it. So I can increase it all the way up to 10. And then if I bring it down from 0 to 1, that flattens it until you hit 0, and then it just becomes the line 0. Y equals 0. And then this, it flips it over. And so you actually can create these animations of how, as you change one of the numbers in the formula, how it changes your graph. It's really, really amazing. Okay, and then this changes the period, right? Right, so I can change my graph. There's my, I got an amplitude of 4. Here's a period. When b is 1, that's just the regular sine function. But then I can increase that and make it oscillate faster, or I can stretch it between 0 and 1. It really stretches it out, and then it'll flip it over. But this actually kind of, look, it looks like a spring. You can actually change the behavior of this, okay? I could put in a C too, and I can make a slider out of that, right? And then by changing that, that'll move it back and forth. So you can do all kinds of stuff. We're going to see in a minute that if you want to do a slider like that, what you would probably do is put a parentheses around this, and you would make this a minus sign to work with that counterintuitive. So this would change the period, and then this here would change the amplitude, and then this would change it going back and forth. And now as I go in this direction, it'll follow my thing, but it's because I have a negative sign up here. Okay, and I could always then put in a plus D and make a slider out of that, and then I could also move it up and down. And so you can do all these different things, okay, and really play with and see how this works. It's really super neat. And to help you play with this, I actually, let me show you. If you go, and right here, I'm working on these, putting these videos together, right? And so if you, below this video, when I get it done, there's going to be this. It says below is a link to Desmos with sine and cosine functions set up with sliders so that you can play with them. So if you click on that, it'll bring up Desmos automatically, and you'll be right in there, and it'll already have the sine and cosine set up so that you can do all the different things, play with it. See that? And where's the slider there? I did something wrong. I'm not sure what I did wrong. Maybe I can add that slider. There we go. You know what? Let me cross that out. Yeah, I can't even do it. Let me go back here. I'll have it bring it up again, and then there's my, I don't know what I did to ruin that slider, but that moves it up and down. Okay, so you got these, they labeled it a little differently than me. And then I could do it for the cosine, I could do them both at the same time, or just do the cosine graph like that by clicking on these. So a lot of fun. You can play around with this. I would take some time to do that if you've never used Desmos before, because you will find it very, very handy, and you could search for it real easy in Google by just typing Desmos, but you can also just click on this link that'll be underneath the video about graphs when we get there. By the way, these are the other ones that I have. These are like these are the flashcards, so you can practice these. Okay, and one thing about this is if you click options here and go here, it might start here, and I don't know why, but what that means is that when you go to the new card, it gives you these, and then you got to guess what it is. But I'm like, that doesn't make sense to me, because it could be multiple answers to that, right? So it makes a lot more sense to do definition like that, and then it'll bring up problems, and then you got to guess it. And then there's some other cool things you can do, but if you do this match, then what they have here, start the game, you want to make everything disappear. So I got them, you know, put these where they go. So sine of 4 pi over 3, that's down here. That's going to be negative square root of 3 over 2. So it's not there where it's like up here. And then I made it disappear and so on. Okay. Can I get rid of that? I can't get rid of it. Okay. But you get the idea. And then down here is also, and then it times you to see how fast you can get rid of all of them. So it really helps you learn these. This is also a neat thing. And as this traces around, this is tracing the x coordinate on the unit circle, which creates the cosine graph. Isn't that neat? And you could do cosine and sine at the same time, or you could do just the sine. Or you might want to do like let's say the cosine, might want to do the cosine and secant together. And then you can see how those are related. See that? So that's kind of neat. Or you might want to do the cosine, maybe the cosine and the tangent. And then you'll see when this crosses the axis, that's where you get the asymptote. And then, so you can play around with this. I'm trying to figure out what this is like the, I'm not sure why it has this thing on there. There's probably something it's trying to demonstrate. But you can play around with that. That animation is on your thing as well. So I better get back to this video. It's getting kind of long. But what I want to do here, so I'm going to go stop screen share. And so what I want to do is just finish this video up about the graphs by doing a couple problems to show you how this is done. So I'm going to graph this function here. And this is as complicated as they can get here because it has everything here. And what you're going to do, if you have both a period change, so this 4 is going to change the period, and you have a phase shift, then what you want to do first, otherwise you're going to get really confused, is you want to factor out that 4, okay? And so to factor the 4 out of here, I got to divide by 4, and I'm going to get minus pi over 8. So in other words, if I distribute, I would get that. And then I get plus 1, okay? So to graph this, first of all, before I mark this, I want to know what the period of this graph is going to be. And the way you get the period is this is the b value. So if you have something like y equals cosine of bx, then the new period is just the old period divided by the b, okay? So for this one, my period, p just for the new period, is going to be 2 pi divided by 4, and that's just pi over 2. So in other words, this thing's going to complete its cycle in pi over 2. So I'm going to have pi over 2 here, and then half of that is going to be pi over 4, and then half of that is pi over 8, and then this is 3 pi over 8. Okay, and then same over here. This is negative pi over 2. This will be negative pi over 4, negative pi over 8, and then this will be negative 3 pi over 8. And now this thing is going to be raised up 1, so maybe I'll do 1, 2, 3, 4, 5. And so this thing is actually going to oscillate around this. So instead of the x-axis, it's actually oscillating around this. And it's going to oscillate between, it's going to have an amplitude of 3. So 1, 2, 3. This will be like the maximum value. This will be the top of the wave. And then 1, I'll do 1, 2, 3, 4, 5. And then it's going to go down 3, so this will actually be the bottom of the wave, okay? And so it'll oscillate. Now, the sine would normally go up like this and down, okay? But this one has a period change as well. So let me, with the dashed line, make what the regular sine would be. It would start here, and then for this is like that first quadrant. It would go up, down, down, and then back up. But now, because that negative pi over 8, it's going to shift everything over 1. So it's really starting here and going up. So my actual graph would be like this, 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 like that. And then this would be down here, up like this, up like that, up like this, and down like that. And that would be the graph of this function. Okay, that is a ton of stuff there. This we spend in trig when we do this in trigonometry or pre-calc, we spend a week or two doing this. So I know I just dumped a bunch of stuff on you. Hopefully you've done this at some other point in its review, but that's the idea here. Okay, now I want to do one more thing and then we'll wrap up these trig graphs here, and that is this is sort of like a real world application. It says that the temperature oscillates, like let's say this is a desert, between a low of 40 degrees at midnight and 90 degrees at noon. Okay, find an equation that models the temp where t equals 0 is midnight and t equals 12 is noon. Okay, so what I'm going to do is I'm going to like make a graph here. And I'm going to have like 24 hours, right? And half of that is 12 hours. So half of that is 6 hours. And half of that is 18 hours. Okay? And so it's like 24 hours split up into fourths. That's 6, 12, 18, 24. And these are going to be like your quadrant angles, really, okay? And now this thing, we want it to oscillate between 40 and 96, okay? So I want to know that line that it's going to oscillate about. And so where's my TI? What did I do? Here it is. Okay. And so what I'm going to do is I'm going to average those two to find the number halfway between 40 and 96. So I'm going to take 40 plus 96, and I'm going to divide that by 2, and I get like 68. So I'm going to just put like the important features on this graph. This is 68, and then up above there somewhere is like 96, and the same distance down below is going to be 40. Okay, and this is that halfway mark. This is the top of the wave. This is the bottom of the wave. And what's going to happen then, it's going to start out at a minimum, and then at noon it'll be starting out there at noon, it'll be the max. So here it's like midnight the next day, right? So these halfway things are where it's going to be here. And this is just like a regular cosine graph, like this, like that, like this, and like that. So this would be the graph. So now what I want to do is I want to find out what this equation is. So first of all, should I use sine or cosine? Okay, well, since this thing doesn't start in the middle and go down, since it's starting at, in this case, the minimum and going up, I'm going to use a cosine. We kind of talked about this on Desmos. I'm going to use a cosine, but I'm going to have it flipped over, okay? So the amplitude is going to need to be negative, and the amplitude is halfway between these two. I'm sorry, it's the distance from the center out to the end. So like 96. Well, I can do it here. It's going to be 28, isn't it? 68 down to 40 is 28. 68 up to 96, or 68 plus 28 is up to 96. So it'll be a negative 28, and it's going to be cosine. And now what I need to do is I need to know what that b is. What am I going to multiply here by x, or I guess t? We're using t here. So what are we going to multiply there by t? Well, whatever that was, to get my new period, right, we would have taken 2 pi divided by b. Okay, now my new period is going to be 24. It's going to complete its cycle every 24. So I got 24 is equal to 2 pi over b. And now what I can do is I can solve this for b, which is the same as saying b is equal to 2 pi over 24. And then this thing reduces down to pi over 12. And so this is what my b needs to be. That's not the period, that's what b needs to be. So this is like pi over 12 times t. Okay, and that's going to change it. So instead of going from 0 to 2 pi, it'll go from 0 to 24. And then the whole thing has to be raised up 68. And that is an equation that's going to model the temperature of this desert, okay, assuming that it oscillates according to this is actually called a sinusoidal wave. The sine wave and the cosine wave are the same wave, they're just shifted around, and we call that wave a sinusoidal wave. And a lot of phenomenon when things oscillate according to this pattern. So it's very, very interesting. Okay, all this stuff is super cool. So I hope you appreciate it. But that's the idea behind the graphs of these. And I went very fast, and I'm really, all these videos, I'm almost kind of compressing a whole semester of Trig. Not quite, because we go into more detail, but a whole semester of Trig in one set of videos. So, but I hope you find it helpful. And in the next video, we will be looking at